This is the product introduction to the AIRCOM solution. AIRCOM is derived from the philosophy of Internet of Things, and the philosophy is that connectivity gives us more power to control our processes and manage them more effectively. In industry, this can be difficult due to large geographical areas that we may have to monitor, whether we're a utility or perhaps a process and petrochemical plant. The AIRCOM device uses LoRaWAN communications, a secure IoT communication protocol born out of the military. LoRaWAN stands for Long Range Wide Area Network and is used to send small bits of data over long ranges. The AIRCOM product was designed in partnership with ARMG in France. The original criteria was for an LoRaWAN transmitter with dual channel IS barriers and a 5 to 10 year battery life to monitor various different instrumentation for a wide range of applications. The initial concept was the AIRCOM devices you see in the screen now. Any instrument effectively can be connected to the AIRCOM device. It will power the instrument, it will collate the data, and then it will transmit it to any command center globally or DCS or SCADA system. Some key unique features about the AIRCOM is it's a Zone 0 Class 2C ATEX device that can be mounted right in the hazardous area. The battery that powers the instrument is also Zone 0 Class 2C, and it can be used to power a wide range of instruments, as shown in the example here, a heart pressure transmitter. The way the device communicates, the LoRaWAN node on the left connected to the instrument passes a LoRaWAN signal over to the gateway, the device on the right-hand side. The gateway can communicate with the customer control system in a variety of ways. In this application, it's using Ethernet to send data via a mobile router, which sends data to a cloud and then onto a physical server. This connection can equally be made to a physical server, or we can provide a Modbus output to go direct into a SCADA system, a PLC, or a DCS. Once the data is collated, the user can utilize various different HMIs to display the data and perform any functions and controls they may need to with that instrumentation data. The AIRCOM device is intrinsically safe, EXIA. It has potentially 10+ years of battery life, and it powers the analog instruments. The full range of inputs for the standard AIRCOM unit has 8 channels. There are over 32 I/O combinations. For instance, there are 4 digital inputs. 2 of these can be pulse or NUMOR, or all 4 could be simple digital contacts, dry voltage contacts. In addition, there are 2 serial channels utilizing RS485 or RS232, and the data can be both ways, send and receive. There are 2 analog channels, and the analog channels can utilize HART, 4 to 20 milliamp, voltage, resistance, RTD, thermocouple, and others. Effectively, the AIRCOM is a multi-use microtelemetry solution that can be used to communicate with a wide range of instruments and to be used with a very wide range of applications. The product is low cost, installation is simple as it removes typical traditional infrastructure such as power, and LoRaWAN is a free bandwidth, so there are no data costs. To configure the device is very simple. It uses Bluetooth Low Energy. There's no pairing required, and is designed for very small packets of data and utilizes very low power and can be used in any standard smartphone. The app is free for download on the Google Play Store or the Apple App Store. This video will illustrate how easy it is to configure and set up an AIRCOM device.
This video tutorial will explain how to get started with your AIRCOM device. If you haven't already, download the AIRCOM app from the Google Play or Apple App Store. Please see our website for the link. First, remove the front cover of your AIRCOM unit and power on by inserting the battery. Wait for the green LED to stop flashing. When ready, gently tap the indicated square with a magnet 3 times to enable Bluetooth. Open the app and select the AIRCOM device you wish to connect to. The name of your AIRCOM device will be the serial number located on the manufacturer's label. Once on the main page, you will be warned that the AIRCOM device clock is out. To correct this, navigate to the AIRCOM device status page and update the device time. You will be notified by a green bar at the bottom of the page when this action is complete. Next, you need to configure the LoRaWAN settings. The first step is to provide your IT department or network provider with the AIRCOM device EUI. This is a 64-bit unique identification number. To find your device EUI, navigate to the LoRaWAN settings page. Next, a 128-bit encryption key, referred to as the app key, needs to be entered into both the AIRCOM unit and your network server. Tap the Edit button. Tap the LoRa app key section and then enter your encryption key. Once you're happy with the settings, tap the Tick button. Next, write the configuration to the AIRCOM device. Return to the main screen and tap the Download Configuration button. You will then be notified by a green indication bar at the bottom of the screen when this action is complete. Finally, you need to join your LoRaWAN network. To do this, navigate to the AIRCOM device status page and tap the Join LoRaWAN Network button. You should receive a green bar at the bottom of the page when this action is completed successfully. You are now ready to configure hardware and transmissions. Please see our other tutorials.
As the video shows, the AIRCOM is extremely easy and quick to set up and install. The app has various other features. For example, on the 4 to 20 mA and other analog channels, a 20-point calibration can be performed for high accuracy. The app has additional features, and there is potential for bespoke features as well, which customers can speak to us on request. In addition, going back to the server concept, the communication, as previously stated, the AIRCOM device sends LoRaWAN packets through to a gateway, which then transmits this data onto the server, whether that be a cloud or a physical machine or a PLC via Modbus. One gateway has the potential to communicate at a 25-mile range, which would be a 50-mile diameter. As the map shows, this is a potentially very large geographical area of coverage, and one single gateway has the potential to service thousands of LoRaWAN nodes or AIRCOM transmitters. There are things that can interfere with the signal, such as topography, and in urban areas, buildings can cause signal attenuation. LoRaWAN is based on the principle of line of sight. So with a clear line of sight, there is the potential to communicate. The current world record for communication using LoRaWAN is over 400 miles, but we have proven that the AIRCOM can communicate stably at 25 miles. These are some examples of installed AIRCOM units in remote locations where there is no power availability and no other comms infrastructure, and LoRaWAN has been utilized to connect. For these applications, the end user has installed the gateway on a preferred location, such as a depot or an office building, and then this data is retrieved from the site. This is merely an illustration of the point-to-point concept utilizing a RS-485 communication. And in this instance, data is being taken from the LoRaWAN node, the AIRCOM, connected to the instrument, and then sent to the gateway, and then sent to the control system via a site telemetry. This could equally be a PLC or other infrastructure. LoRaWAN is inherently secure. The way LoRaWAN works is it uses a 64-bit unique identifying code for every node. Each node then has a 128-bit encryption key, which is to the AES encryption standard. The server will automatically, or an individual can randomly generate a 128-bit encryption code. This is manually inserted into the AIRCOM device, and then the identification key is also put inside the server so that the server will know to receive a command to connect from the AIRCOM device, a join request. Once this happens, the server then issues a new encryption key to the LoRaWAN node, and the connection is made secure.